Hello viewers, okay, let's start our session. If this is Sriram from High Maths Academy. If you are watching first time, please like, subscribe, and share the link to your friends and make your friends to learn of algebra. Let us see what we are going to discuss in this session. And if you have any queries, please raise in the chat box. I will answer your doubts. And let's start our session. See, if you are okay, please just click like button here. Then I will start with this. Okay, let's start. See what it actually algebra means and what we are going to cover in this session. Let us see. Let's see a quick review on this. See, in this video we are going to cover an introduction part, how why we are necessary to do this algebra, and some matchstick patterns to understand the concrete things where we will come across with this algebra, and how to make rules with the help of algebra, and the concept of variables and use of variables in the common rule and algebraic expressions, and formatting a simple algebraic expressions from word phrases. So there are some vocabulary which we need to be concentrated in this algebra to frame the given situation into to frame a given situation into an algebraic expression or a mathematical statement, and statements from algebraic expressions and values of algebraic expressions. Let's start our session. Let's give a brief crispy introduction for it. See, we already learned about the numbers, and we have did various operations on the numbers. See, the branch which deals with the numbers and various operations is known as uh, arithmetics. Is known as arithmetics, and we all are familiar with some other branch of mathematics where we will come across the shapes and their properties and their dimensions and their measurements. That branch is known as geometry. And now we all are going to learn something new, and it is an abstract thinking. We can't say we can't guess this abstractness, and we can think something which is beyond the box and beyond the textbook. That is nothing but algebra. So algebra is basically known as, it's a branch of mathematics which deals with unknown values, unknown values. So algebra is going to use of letters. So for these unknown values we are using the letters and places of numbers with simple interest patterns, some interesting patterns. So let us see what is algebra about. Let us take some views on it and see here matchsticks pattern. If you observe this pattern, here two matchsticks are arranged to form the letter L, and here uh, two L's are formed. Here till here it is one L, and here it is another L, and here three L's are formed, and so on. See, let us see what we are going to do here. See, these letters L's are formed here. We can use two mastics to form a letter L, and number of mastics for one letter is C. Let us check the number of mastics we are using for the letter L. For one letter of L we are using two mastics, and for to forming two L's we are using here 2 and here 2. Total 2 into 2, it is 4 mastics we are using. For forming 3 mastics we are forming 3 into 2, that is equal to 6 mastics, and so on. If you want to make 4 L's, how many matchsticks we can use? 4 into 2, that is equal to 8 matchsticks. Now if we add on one more L next to the 2 L's and 3 L's. Similarly, if you are moving. Similarly, if you find for the 5, what will be the for 5? If you want to make 5 mastics, you need to make 5 into 2. For suppose, if you want N L's, if you want N L's, see, can you observe any pattern here? Can you observe any pattern here? Yeah. If you know, if you observe any pattern, please text me. If you observe any pattern, please text me. If you want to find NLs, what will be the answer? Maybe. Can you please text? I am giving 5 seconds of time. Shall I count? 1, 2, 3, 4, 5. Okay. I will only tell. See, for making NLs, we require n into 2, that is equal to 2n. See here, we don't know actually what is n means. N may be 10, n may be 5, n may be 6, n may be 8, n may be 100. For example, if you want to make 100 else, how many you make? If you want to make 100 else, the formula is 100 into 2. For every L we require 2 mastics. So 100 into 2, that is 200 mastics we require. 200 mastic we require. Okay, let us continue it. We can see that a number L increases in above pattern. So mastics are 2 times the number of L's. So this is the logic here. So number of mastics required is equal to 2 into number of L's. Yes, this is the pattern we are using here. What is the pattern we observe here? This is the rule and the pattern we are observing here. If we write n for L, where n is equal to 1, 2, 3, therefore we are getting a rule of number of mastics is equal to 2 into n. 2 into n. By using this rule, we can find the number of mastics required for any pattern of L. For any pattern. Let us see one more example. See, similarly, we can use, see, if you observe these patterns, we are having different forms and we are using, everywhere we are using mastics only. Here to form F. How many mastics we require? 1, 2, 3, 4. Now for the next L, for if you want to make 2 L's, if you want to make 2 L's, 1, 2, 3, 4, 1, 2, 3, 4. So here it is 1F, so 1 into 4. Here it is 2 F's, so it is 2 into 4. And here it is 3 F's, so it is 3 into 4. So everywhere if you observe 4 is common. The number of F's increasing, so that many number you need to multiply with 4. That number you need, if you want 5 F's, so you need to multiply 4 into 5, that is equal to 20. So here this is the formula for F. Now similarly we have next, what is that? T's. One T require 2 mastic, for 2 T's it required 4. Similarly like L, T also having a 2N. For making Z, C 1, 2 and 3. For 2 Z's it is 6. For 3 Z's it is 3. So 3 is common. If you require 1, 3 into 1. If you require 2, 3 into 2. If you require 3, 3 into 3. If you require 4 Z's, you need to multiply 3 into 4. For E how many E require how many mastics? 5 mastics. 1, 2, 3. See how 5? 1, 2, 3, 4 and 5. So for 1 it is 5 into 1. For 2 it is 5 into 2. For 3 it is 5 into 3. For 4 it is 5 into 4. For 6 it is 5 into 6. For if you want n, if you want to make n, it will be 5 into n. Now see, here we are making the squares. For one square we required 4 mastics. Am I right? And here this if you want to make 2 squares, see, one square we required 4 mastics. If you want to make 2 squares, we will use one of its side. we will use one of its side and we will take another like this 3. If you keep 3 mastics, we will get 2 squares. If you want to extend it again, if you want it 3, you can join 3 more mastics here. If you want 4, you can join 3 more mastics here. So here you can observe this. This is different kind than the before what we learned for the rest. This is a different kind than the before what we learned here. So here for whatever number it is, for first one what it will be 4 confirm, and for the next 3n plus 4. If you want for suppose if you want 2 mastics, 2 squares, how many we got? Actually 4 plus 2, 4 plus 3, 7. Let us see whether it is working or not. So if you want to make for suppose 4 squares, so in the place of n you need to put 4 and plus 7, simplify it. 3 4 7 plus 1, that is equal to 8. See, total we are getting 8 mastics. Let us check. 1 2 3 4 5 6 7 8, sorry, 3 plus 4 is 12, 3 into 4 it is, 3 into 4 is 12 plus 1 it is 13. 3 into 4 is 12 plus 1 it is 13. 3 into 4 plus 1, 12 plus 1 it is 13 mastics. Let's count. Here for first it is 4 plus 3 7, again plus 3 13, sorry 10, and plus 3 13. Total it will be 13 mastics we are using for 4. Similarly, if you want to find n squares, so you will require 10 squares means 3 into 10 plus 1 31. The same pattern will follow for rectangle. See, it is also a kind of different thing what we observed from the above. These are of one kind and these two are of some other kind. A little difference is there, you need to be observed carefully. For one triangle we required 3, and for 2 already we will use one mastic in the from the previous triangle. So extra we are keeping 2. So similarly we required it is having 2n plus 1. See, let us see an example here. We will explain a little bit more. For triangle we will do now. See, for triangle actually we require 3 mastics. This is 1. And for this same triangle, if you want to extend one more triangle, we will include only 2 mastics here and here. 2 triangles it form. Now if we want another triangle, for the existing 2, we are adding 2 more mastics here, here and here. So we are adding how much? 2 extra we are adding. So the formula will be 2n and plus 1. Why? Because if you want 3 mastics, 2 into 3 plus 1. So it will be 6 plus 1, that is 7. For every triangle we require at least 2 and 1 for the closing one. First one. So there are 7 mastics for 3 triangles. Similarly, see here this is another kind. C, we are forming C. For one C we required 3 mastics. For 2 C's we required 3, 3, 6. For 4 C's we required 4 C's 1, 2, 3, 4. 4 into 3. So for C it is 3. Okay. Now let us see the next. Concept of variable. From where we will get this concept? From where we will get this concept of, let us see from where we will get this concept. Variable is nothing but which can able to vary, and here the value of the variable is fixed. The value of the variable is fixed, and it can vary from condition to condition. For example, there is a number which is if you add 2 to it, it will be gives 5. If you add 2 to it, it will give 5. If you add 2 to it, it will give 5. So can you guess what will be the number? The number will be the, can you please chat it? The number will be the, yeah, if you add any number to 3, it will gives 5. What will be the number? What will be the number? Yes, it is 3. It is 3. 3 plus 2, it is 5. So this is the value we don't know. But suppose in that value, if I am taking n plus 2, which gives 8. So what will be the n value here? What will be the n value here? If you add 2 to n, it gives 8. So n value may be, what it will be? 6. Yes, exactly. The same. Now I am giving another situation. 2 I am multiplying with a number n, it gives 10. It gives 10. So what may be the n value here? The n value may be 5. Yes, obviously correct. 2 into 5 is equal to 10. So the same n here I am using and here I am using. But in this situation it is taking 6 value, and in this situation it is taking value of 5. So the same variable taking different values according to the situation and according to the condition. So we conclude that value of the variable is not fixed. So the value is different as the situation required. For variable we can use English alphabets, especially the small alphabets A, B, C, D, so on. We will use these alphabets for variables. So variables we can conclude that what is variable? The symbols which can vary its value, means which can change its value. It doesn't have any fixed value. It takes the value according to the situation where it is there. Okay? And see, let us see the another next concept where we will use these variables. The thing is where we will use these variables. Where we will use these variables. Let us see. See, to frame the rules in the geometry, we required variables. To frame the rules in the geometry, we require variables. To frame the rules in the geometry. What type of rules? See, if here you are taking the square, and if you want to add the boundaries of the square, since boundaries of the square are equal, every side is having equal measurement in the square. So what it will be? If there is a square here and we are adding it, if each side is a units they given here, and if you want to add it, four sides are there and four times a is repeating, so we need to add a plus a plus a. So how many times repeatedly we are adding a? So that is nothing but 4a. So this gives the rule for perimeter of a square. So this is one of the example, best example where we can use this variable. So getting the formula, framing the formula is an application of an algebra. And similarly for rectangle, if there is a rectangle with length L and breadth will be B. So we know that in rectangle opposite sides are equal, and we want to find the length of this boundary. So length plus breadth plus length plus breadth. Each and everything we need to add. See how many lengths are appeared here? Two lengths. How many breadths? Two breadths. So 2L plus 2B means 2 into length. 2 length means what? 2 into length plus 2 into breadth. Why? Because repeated addition is nothing but multiplication. So 2L plus 2B. And this can leads the algebra here to frame the formula for a perimeter of rectangle. This leads the algebra to frame the formula for rectangle. Let us go to the next. And we can also use this algebra in arithmetics also. Actually, we know that in arithmetics we will discuss about only the numbers. Yes, absolutely true. But we learned in the 6th and 7th standard some properties of integers, and properties of integers, and properties of whole numbers, properties of natural numbers. These all we learned now. In that properties, sometimes we discuss it using some symbols like ABC. Let us see an example. Commutative property of addition of two numbers. We know that commutative means if you even if you reverse the order, we will get the same number. 5 plus 2 is 7, 2 plus 5 is 7. So if you want to generalize this property, we will use some symbols like a plus b is equal to b plus a. This indicates the property rule, commutative rule. Instead of numbers, we use the symbol ab, and it is a generalized one. So in what now we are getting another one. To generalize the properties, we will use variables. This is also one of the application of variables and in the algebra. Now commutative property of multiplication. So we know that 5 into 3 and 3 into 5 gives 15 only. Similarly, we will generalize this for A into B and B into A into B and B into A. Let us see the next one where we will use. See, and we also use this for associative property of addition. We know that the grouping, regrouping. So this general thing is 8 plus 10 plus 7 is equal to 18 plus 7, that is 25. Now we regrouped this 8 plus 10 as 10 plus 7. So 8 plus 10 plus 7 means 17. 8 plus 17 is 25. So what we concluded is the both are equal. This one we generalized for all numbers. Such a way, a plus b plus c is equal to a plus b plus c. So to generalize the properties, we will use algebra. Similarly, here we have an example of distributive property. And let's see, and some more examples we will check. See, we know that perimeter of equilateral triangle of a side L. The side measurement is given in equilateral triangle. We know that all sides are equal. So to frame this formula, we required a sum of length of all three sides. That is 3L plus L plus. What is the perimeter of equilateral triangle? L plus L plus L, that leads to 3L. Similarly, perimeter of regular hexagon. Whose side is L? Regular means we already learned what is meant by regular figures. So regular means all sides are equal. In regular hexagon, hexagon means 6 sides we are having. So sum of all 6 sides, 6 into same number, same length we are adding. So 6 into L, 6L. Similarly, length of the edges of cube. See, cube we know that 3D shape. In cube, how many edges we are having? We are having 12 edges. We are having 12 edges. These all 12 edges. These are all having 12 edges, and so we are multiplying 12 into L, 12L. And diameter of a circle of the radius. See, we know that in a circle have infinite radius, and its diameter will be twice of its radius. Twice of its radius. So R plus R, it will be 2R. I think all of you are concentrating on the listening. So if you like this session, please click the like button. If you want your friends to be learn, please ask them, share the video and ask them to be in part of this. And let us see something new that it is very interesting. This, see, in this algebra, we are talking about the variables which can change the values. I think you will get one doubt here. Sir, what about some symbols which doesn't change any value? Yes, there are some symbols which doesn't change any values. What we will call them? Let us see that we will see in the coming things. Now, algebraic expression. We all know what is mean by expression. We already know about the addition, subtraction, multiplication, and division are the basic mathematical operations. By using these operations, we can form some expressions. For suppose, if you there are two people, one is A and one is B. A is having 15 rupees and B is having 20 rupees. If we want to know what will be the total money with them, so how they will express, they both should express by using the positive plus. So 15 plus 20, they are having together 35 rupees of money. So they are expressing their total sum total money by using addition. For suppose how much they are differ, how much money they are having difference. So in what way they will express that difference? They will do subtraction to express their difference. That will be 5. So an expression includes arithmetic operations like addition, subtraction, multiplication. Let us see this algebraic expression formed by using the mathematical operations on the numbers. This is arithmetic expression means where we will include a numbers. 3 plus 4 into 5, 7 minus 2 plus 3. These all are the arithmetic expressions where we are using numbers. Coming to the algebraic expressions, instead of numbers and including numbers, we will use some unknown values means like a variables. We will use some variables like 4n means 4 into n. There is a number which getting 4n value. And here it is another expression 2a plus 3, 10x minus 7, similarly x plus 5, etc. are some algebraic expressions. See, and we can also learn many other things, some basic word problems. Let us see. And these are the day-to-day applications where we are using, and these are the words related to our algebra which helps us uh, to better understanding and to better performing this algebra chapter. See, words that leads to addition. See, if you observe some, more than, increase, plus, altogether, add, these words generally used for addition. And words which leads to subtraction. If these are the clue words which tends us to do subtraction there, taken out, decrease, less, difference, minus. These words generally used for subtraction. And let us discuss some more words which leads to multiplication. See, times, multiply, multiple times, product. Such words are used for multiplication. And words which leads to the division, divide or division, used for division. And sometimes see words which will we are using in the addition, sometimes we can also use for multiplication too. So here words which leads to division is divide or division. And we know that division is the repeated subtraction and multiplication is repeated addition. So sometimes the addition words may relates to that multiplication, and sometimes these subtraction words relate to this division also. And most importantly, these are very important words. These are the vocabulary which makes us better to learn algebra. Let us see some examples on this where we are using this and how to express this when we find this type of words in the context. Let us see, here are some examples. Algebraic expressions for word phrases. See, here they given 10 more than a number. So more than means what? We already learned. More than means plus. How much it is more? 10. A number. We don't know this A number. So we don't know. We are talking about an unknown number. A number, it may be 10, it may be 5, it may be 6, it may be 7. So instead of that, we took that A number as an n and we are adding it to 10. So the expression we got it n plus 10. A number decreased by 5. We don't know that A number. It's an unknown number. So here I am using W. You can use X. You can use A. You can use B. Whatever it may be. You can use any symbol to represent that A number. Decrease. You need to concentrate on this. You need to concentrate on these words. Decrease means what? Subtraction. Decrease means what? Subtraction. So we are using subtraction, minus. 6 less than. This is the keyword. Less than means you need to subtract. 6 less than a number. So x minus 6. A number increased by 5. Increased means what? Plus. Increased means positive number. Plus. Increased means we are increasing more than. Plus. Increase. Sum. And sum is the keyword. You need to observe these words. Sum of a number and a 9. A number हमको we don't know. So we are using t plus 9. And a number y plus 2 they given here. See, if you observe this one, clearly they mentioned a number is y and we need to do plus 2. That no, y plus 2. 7 is added to k. Now instead of talking about a number, they are giving directly that letter. 7 is added to k. So k plus 7. 2 is taken out from p. So p minus 2 taken out means subtraction. P minus 2 and y is divisible by 8. So y is divisible by 8 means y divided by 8 or else y upon 8. Anything is fine. N is multiplied by 2. See, it is a little bit complicated one. N is multiplied by 2. So I am multiplying n with 2 and it's not yet completed. Still something is there. 1 is taken out from the product. Product means this is the whole answer. From this we are subtracting 1. So it leads to 2n minus 1. See, these are the various situations. So you need to familiar about the keywords. And if you learn that keywords, it is easy to understand this algebra and it is easy for you to, and it makes more interesting. Let us see some more. See, x plus 7 is the statement given, expression they given. How to express this in the statement form? 7 more than a number x. 7 more than a number x. T minus 5. We are subtracting. We can use taken out or else see 5 less than. You can also say for this 5 less than t. This is not the only way. You can take say anyway 5 less than t and see here it is a 2x plus 3. 2 times a number you can say or else twice a number also you can use. Twice a number is increased by 3 or else you can also say it as 3 more than 3 more than 2 times a number. 2 times a number. This is also fine. And see, p is dividing 5. P by 5 or else p by 5 you can say p divided by 5. This is the way to you can say. Let us see some more. See. And algebraic expression is there and we can also check for the values what it satisfies. X plus 8 they given the algebraic expression and if suppose x is 10 you need to place the 10 instead of x. So x plus 8 will be 10 plus 8 that is equal to 18. If suppose if I took x value as 3 or something, if suppose x value I took as 3, then what will be this equation? 3 plus 8 that is equal to how much? 11. Similarly for the next one, see next question, next k minus 3. Here they given k is 15. If suppose k is 15, what will be this expression value? 15 minus 3 is equal to 12. In the place of k, we are replacing it with 15. Why? Because they given that. So it is nothing but substitution. 2x minus 3. Here x is given as 3. So I need to replace x with 3. 2x minus 3 will become 2. 2x का मतलब क्या है? 2x means 2 multiply by x. 2 multiply by x. So 2 multiply by x means 2 multiply by 3 minus 3. That is 6. 2, 3, 6 minus 3. That is equal to 3. See, on practice you will get these all. You require some little more practice for this. And if you know everything, it is easy. So practice makes it easy. K by 7. It's nothing but k divided by 7. K is equal to 28 divided by 7. So 28 upon 7 that is equal to 4. So 2t plus 3. So here t is given as 5. 2t means 2 into t, 2 into 5 plus 3 that is equal to 10 plus 3 that is equal to 30. Okay. This is the basic algebra which we are learning in 6th and it is a recall for 7th standard also. In the next section I am coming with some extension of the topics. If you like, so stay tuned to the channel, and if you want any suggestion please comment below, and if you want any requirements please comment below. I will update my next classes there. And thank you for being with me, and thank you for watching. See you yours. Bye. Thank you.